Okay, so good morning, everybody, and well, my name is Boris Wenzel, as you heard, and I'm the president of TIC 4.0, which stands for Terminal Industry Committee 4.0. And first of all, thank you to Holger and Oliver for having me and giving me this opportunity to kick off this conference with this keynote and to talk about the importance of the terminal industry to adopt common standards. And this is for communication between equipment, operating system, and subsystem. But because I thought the title was a bit boring, so I put a bit more philosophical subtitle. So I thought it's about the metaphysical quest of TIC 4.0 to make humans and machines communicate between themselves and with each other. So I think now you're a bit more interested to listen to what I'm going to say. So first of all, we need to ask ourselves, why are common standards needed for the port industry? Because after all, our industry has been operating without these for decades. And indeed, for a long time, terminals were just equipment and people moving boxes. But as terminals operations became ever more complex with larger ships exchanging increasing volumes, the TOS, the operating system, have become more critical in managing terminal activities. And I think our friends at Aquinet know that very well. But to further increase efficiency, the industry now needs to connect all the equipment and processes with each other. And optimization of terminal operations with software solutions requires interconnectivity and data. But this is also actually not enough, because you need not only to connect equipment, but also to be able to use the data that is generated and extract value from these interconnections. So, and who is going to extract value from these interconnections? Well, it's actually the software provider. And it is for this reason that the industry, our industry, joined together to create TIC 4.0 to work jointly on the elaboration of common standards. And I will show you in this presentation the outcome of using standards in a smart way, allowing you to integrate systems at a very low cost and to achieve results. So let's start with asking the question, why do we need common standards for the port industry? Moving to digitalization or automation, which also requires digitalization, is something many other industries have done over the past 40 years. The question is, why is actually our industry so late in this transformation? And one major reason is that the benefit was not so huge in comparison to the risks and complexity. And that is why today there's only a low digit percentage number of ports in the world that are semi-automated or fully automated. The new technologies which are available today, such as IoT, big data, machine learning, artificial intelligence, are all powerful tools, but they're only useful if you are able to feed them with the right data from the equipment. And this data also needs to be understandable by humans, because we want to use the data to understand the reality and to continuously improve it, not just to automate. Otherwise, it's also not so useful. And this is really the catch. Once we can reduce the risk and complexity of digitalization, it will spread much more quickly through our industry. And it is then likely that things like the DMAIC approach, like define, measure, analyze, improve, and control, for improving existing process problems, process automation, and finally equipment automation, will become much more widespread in the terminal industry. Our industry is very inefficient by design, and there are two big factors behind that. Firstly, the process is discrete, not continuous. The vessel arrives when it arrives, and there's no activity when there is no vessel. Secondly, even when there is activity, because of the irregular performance of the different elements of the internal logistics chain, it results in the equipment actually idling, meaning it's waiting for cargo most of the time. So as a result, the process is very inefficient. So we have two approaches to improve this. The first one would be to redesign all the logistic chain to ensure a more continuous process, which would be very complex and expensive and probably not worth it. The second approach is to use data to optimize the existing process. And changing the industry to improve its efficiency using data, but without reinventing the wheel. I mean, this is actually what companies such as Amazon, Netflix, and Tesla are doing in their respective industries. And let's actually take Tesla as an example. I mean, Tesla did not invent the wheel, the car, or the electric motor. Tesla was originally founded by computer engineers, and they started to build cars, but were thinking out of the box. And in a Tesla, it is actually the software that makes the car super efficient. Tesla cars have the best efficiency in the market, but all their hardware is in fact comparable to that of other car makers. So now all the big groups, and I heard some of you or many of you are on this conference, have started to realize the importance of the use of data and trying to take advantage of all the data they're generating in the activity. And it was not the case even just 5 years ago. And this is why digitalization has taken so much importance recently. Joining data, integrating it to address low efficiency. In other words, do more with the same. But to be efficient and profitable, this needs to be done cheaply. Otherwise, it is difficult to justify it to your CFO. So this is why common industry standards are important, because when you want to connect multiple different equipment from different manufacturers with different systems and subsystems and digitalize your processes, it's only with common industry standards that you can do this cheaply and with a low risk. Otherwise, each time you change your engineer or your equipment or software version, you may need to start from scratch to rework all the interconnectivity and sometimes also all the data model, etc., which will meaning, in fact, all the data interpretation. And this is where TIC 4.0 plays an important role. So several leading terminal operator groups and prominent port equipment manufacturers and solution providers. Some of you actually on this conference today immediately subscribed to the notion that we needed standards for the industry when it was put forward as a proposition in 2018, because they all believed in the benefits of working with common standards being greater than each individual player keeping its own standards, thinking that it provides it with a competitive advantage. And this is how, together with some of the biggest names in the container industry, we have created TIC 4.0. Here you can see the objectives of TIC 4.0 that we defined and that guide us today. But what is really important to understand is that we are actually working on creating an entirely new language, understandable by humans, but which is also understandable and used by machines, and that will allow the full digitalization of all equipment assets and processes that you can find in any terminal anywhere in the world. And this is, and Holger mentioned it, this is what experts and geeks today call the digital twins, but we are envisaging this to cover 100% of the port terminal reality, meaning the machines, all the components of the machines, such as wheels or brakes, processes such as moving or loading a container, carrier visits such as external truck visits or vessel visits, etc., and all in such a way that you would, in theory, never need to even go to the terminal to know what's happening or what will happen there. So we have today 27 members, and you can certainly, for some of you, recognize yourself or otherwise recognize very familiar names from the industry. All these companies that have joined TIC 4.0 believe that they cannot digitalize without common standards for the industry. And TIC 4.0 is an open association, and of course we welcome any company active in our industry, either as an operator or a supplier of equipment or technology to join us. And if you want to take part to the effort to create our industry language, maybe you should actually join us. So here are a few milestones of the short history of TIC 4.0. I'm not going to go through it, but the important thing now is that we are working towards having our TIC 4.0 standards recognized as BSI publicly available specifications within the next 2 years, which is like an intermediary phase before we will have them formatted and recognized as ISO standards, which we expect to be achieved within the next, let's say, 5 to 6 years after they have been really tested in the industry. So we have made 3 publications so far, all in 2021. and have the fourth one that is scheduled in the first quarter of 2022, which covers the topics of health, carrier visits, cargo metadata, and drive. And we hope to also be able to finalize the data schema with this release. From then on, we expect to have about 3-4 publications per year. Of course, everything can be downloaded for free from our website. So now let me get a bit in the heart of things. And defining the scope of TIC 4.0 is something that in a certain way, as I said with a subtitle, borders metaphysics, because TIC 4.0 is developing a semantic, which is the ontology. And by ontology, I mean the way you express or build a reality, or if I also checked the Oxford's definition, which says it's a set of concepts and categories in a subject area or domain that shows their properties and their relations between them. So as I said, we are developing an ontology that allows the humans and machines to communicate, but not only. The specificity of the TIC 4.0 semantic is that it allows human to human, human to machine, machine to human, and machine to machine communication. And the data set is the database with the short definitions for each individual data schema. And finally, the data schema ensures the consistency of all the messages that we create. Yeah, with the semantic, we are creating sentences by combining basic elements as shown here. Every value is defined by combining, I think you need to click here, by combining subject, concept, observed property, and point of measurement. And I will give you now an example on the next slide. So this is how the semantic looks like in a flat format. As you will see with this example, you can write an email or receive a plain text message using the TIC 4.0 language we are developing, and that both humans, well, at least let's say some humans and machines can understand in a straightforward way. So here is it's an extract of the same message in a JSON format, and I believe you're familiar with JSON. Otherwise, it stands for JavaScript object notation format, and it's commonly used because it's quite a flexible data interchange format that is also easy for humans to read and write, and for machines to parse and generate. But it is important that you understand that the approach of TIC 4.0 is not to impose the use of any specific protocol such as JSON, but precisely to develop a semantic that is universal and can be applied to any protocol, such as some of them I put on the left side of the slide. Now, this is how the data set looks like. And in the end, it's like a database. You can search for definitions and how the definitions are interlinked. These are the definitions related to the activity of container handling equipment, for example. And this is the example in JSON format of how the container handling equipment data model looks like. And we're here showing a small snapshot of some subjects and concepts that are very popular in our industry. But the full extension of this data model is now 20,000 lines and growing as we try to express any reality that is important for our members. And when you want to express something related to the machine, this is then how it looks like in a JSON format. And you can see that you have a lot of realities represented in this data model that effectively it becomes the virtual object of the machine. So, and if you need some information on the machine, it would therefore be represented in this data model. And this is therefore the complete register we have to represent a container handling equipment. So here, same for the TOS. I think you have to click again. Yeah. The TOS and processes, it's now 7,000 lines and growing. We call it TOS because it is the main process driver. For sake of a better name. And next. Yeah, our data model is very extensive for the container handling equipment and the CHE. We have already 20,000 lines of JSON, as I said. And we have to develop a lot of concepts that need to have the same meaning for everybody and can be used in any terminal in the world. And by assembling concepts, we form attributes or sentences, as I mentioned before, which describe a specific reality in a terminal. And at this stage, we expect that there will be upwards of 5,000 attributes that will result and be used in digital twins. And these attributes will be in such a way that they can be read and understood, as I said, by humans as well as by machines. So now let's get to something a bit more interesting, because I'm going to just talk a bit about iTerminals 4.0, which is a project. You can go to the next one. I'm just going to skip because I'm already taking a lot of time. So this is a European project, European funded project, where we actually put into applications the TIC 4.0 standards that we create in a big data application on a terminal in Malta. And there are many, next slide. There are many applications for this. These are some examples of how we try to actually use data to improve efficiency, safety, maintenance capabilities. But let me take you through actually all this through a video on the next slide. Yeah, and if you can just click play, and you'll hear a bit of music, and I'm going to comment on top. So what we wanted to demonstrate is that using data, I can't hear the music though, huh? Using data, we can improve almost every aspect of the terminal. And with standards, the cost of digitalization is very low. And this big data can help improve any aspects of a terminal activity, operations, productivity, health and safety, procurement. And in fact, these concepts and features I've been talking about is not a theory. And as I said, we have this terminals project in the terminal in Malta, which is, as you know, a major transshipment hub in the middle of Mediterranean, where thanks to the IoT technology, real-time data, and the latency is about 2 seconds for raw data, 8 for fusion data, and which is connecting now nearly all the equipment in the terminal. And the data is then stored without limit thanks to big data on a digital platform. And so now the raw data is very easily accessible. In fact, it's much more easily accessible than on a classical database. Move data, status, spreader, hoist, trolley, engine, timers, a lot of timers, power, energy, almost any single interesting value is available. And the business intelligence tool allows us to represent the raw data in a graphical friendly way across, as you can see now, across time and or bucket per any meta data you can think of: working, driving, idle status, any timers, eco consumption status, and any counters such as moves, boxes, cycles, cost, etc. So the dashboard regroups all these visualizations on one page, so you can see all of this data together in real time, synchronized and harmonized. Now the data is available and ready to be used for any service, such as a cloud TOS that you can deploy at a minimal cost. And you can also put smart plugins, as was just shown. It can then also be deployed at a minimal time, with minimal time and effort. And Malta has already integrated a digital platform with several manufacturers. Konecranes and ZPMC are already done, and I haven't checked, but I believe Heister and Kalmar should be almost done, if not done already yet. And very soon, all the equipment will be fully connected to this big data platform using the TIC 4.0 open protocols. So now a few conclusions. So in conclusion, I think the most important takeaway is to understand that the best alternative we have to improve terminal business is using data. And to make the full use of data, you have to be able to create a digital twin of whatever your business is, whether it's a machine, a component, a process, or software. And if you want to integrate your physical or virtual product in our industry, then actually you actually maybe want to join us to make sure it will be fully integrated. So this is a picture on the, you can click now. Yeah, this is a picture we took actually a couple of years ago when we met one of our meetings. As you saw, now we are 27 members, so our meetings are rather close to 40 people now. And we are very happy to give you more information if you want to hear more about TIC 4.0, if you think you should actually be part of it. So I just look at my timer. I took 20 minutes for this, Holger. I'm sorry if this was a bit long. I hope it wasn't too boring, and, and that some of you learned something out of this. And I'll try to stay on till the end of the conference if there are any questions.